Alright, so now we're going to be looking at problems 7 and 8 in this video. And to understand problems 7 and 8, we need to understand the compound interest formula, which says that the amount is equal to the principal, which means the initial amount we invested, times 1 plus r over n to the nt power, where r is the rate, the interest rate as a decimal, and n is the number of compounding periods. T represents the years. So if we want to figure out our balance after 2 years in an $8,000 account that pays 3.5% interest compounded quarterly, well, that's telling us P is 8,000, R is 0.035, which is that percent as a decimal. Compounded quarterly tells us N equals 4. We want to consider T equals 2 years and then T equals 10 years. So for 2 years first, we're going to do 8,000 times 1 plus 0.035 over 4 to the 4 times 2. And then for 10 years, we're going to do a similar calculation, but it's going to be 8,000 times 1 plus 0.035 over 4 to the 4 times 10. And we are going to type those into Desmos. Alright, so I have typed those calculations into Desmos, and now I've got my values. So $8,577.45 for 2 years and $11,335.27 for 10 years. I can just write those down. That was $8,577.45 and $11,335.27. Now, when will the account balance reach 20,000 is a separate question. They're giving me an amount, so 20,000 replaces A. I know the principal is 8,000, so now I have 1 plus 0.035 over 4 to the 4t. T is what's unknown here. We don't know the time it will take. So I want to solve this equation, and first thing I need to do is I need to simplify this expression. So 1 plus 0.035 over 4, let's see what that is. You can see there at the bottom, 1 plus 0.035 over 4 is 1.0087. I need to make sure I keep all those decimals, no rounding. .875, my bad. So to the 4t power times 8,000 equals 20,000. We're going to divide both sides by 8,000. 20,000 divided by 8,000, that's 20 over 8, which is 10 over 4, which is 5 over 2, so 2.5. So we have 2.5 equals 1.00875 to the 4t power. Now we can take the log base 1.00875 of both sides of this equation. Those cancel out, and so now I'm going to rewrite the equation over here. We have 4t. I'm flipping sides. Maybe it'd be best if I don't do that actually. So log base 1.00875 of 2.5 equals 4t. So last step is I need to divide both sides by 4. And so this is what I'm going to type into Desmos to get my final answer. So log base 1.00875 of 2.5 divided by 4, and that's 26.3 years. All right, so that's number 7. Let's go on to number 8. Same concept, same formula. So I'll write it down again. A equals P times 1 plus R over N to the NT. Good formula to have in your notes since the test is open note. Your friend has a credit card debt of $300 being compounded continuously. So when we have compounded continuously, this formula actually changes. And instead of 1 plus r over n to the nt, continuously means we're using e. So we have pe to the rt. And so writing equations to represent this scenario, we would have a equals 300 e to the 0.14 t. How long will it take until this debt becomes 8,000 if he doesn't make any payments? So 8,000 equals 300 e to the 0.14 t. We're going to use a similar process that we used last time. Divide both sides by 300. So we're going to get 80 over 3 equals e to the 0.14 t. I don't want to round anything. In the last problem, 2.5 was exact, so I didn't round it. But on this one, 80 over 3 is not exact, so I don't want to round. How do we undo exponential expressions base e? We use ln, so that cancels out. Going up here now, I have 0.14 t equals the ln of 80 over 3. And so final step, I divide both sides by 0.14 to get my solution, approximate solution. ln of 80 over 3 divided by 0.14 is 23.45, which rounds to 23.5. So that's a massive accumulation of debt, which is why it's important to pay off credit cards. Problems 9 and 10 will be in a separate video.